We all have heard it. Elon Musk is preparing to broaden the internet connectivity using a mesh of satellites traveling on the low Earth orbit. He has been recently sending many satellites to space to achieve this as quickly as possible. They recently started offering beta testers a Starlink service terminal that includes an antenna and router for $499 and $99 a month for internet service accessible from anywhere. But many other companies are trying to achieve the same goal of increasing internet connectivity. They all somewhat differ from Starlink in how they launch satellites and satellite technologies, but try to achieve a similar end goal. In this video, we will compare and contrast the satellite specs of those competitors with Starlink to better understand the current state of art and success potential. They plan to send 42,000 satellites to low Earth orbit with altitudes ranging from 210 to 750 miles above the ground. But before we start, let's answer an important question. We already have satellite internet, so why do we need more LEO satellites? The reason for companies are targeting the LEO is the proximity of satellites to the Earth. LEO is defined as an orbit with an altitude less than 12,000 miles above the ground. Being closer to Earth enables faster connections and low latency, which is quicker signal transfer, and also lower launch cost per unit mass. However, LEO satellites are not stationary with respect to Earth and have smaller area coverage. Therefore, they need more satellites to cover the same amount of area of Earth. Although coverage area is large for satellites at higher altitudes, they are costly to launch as they need to reach higher orbital speeds and altitudes. Now we will take a look at the companies focusing on developing satellites for low Earth orbit. Low Earth orbit is defined as an Earth-centric orbit with an altitude of fewer than 1,200 miles. Amazon Project Kuiper. Similar to SpaceX, Amazon is designing a satellite to achieve internet access. According to what they unveiled, they invented a cheaper and smaller Ka-band phased array antenna that combines receiving and sending signals together, thereby reducing the overall cost of the system. According to Amazon, this technology is enabled by analyzing the customer behavior of transferring data from the internet. As the amount of people send is much smaller than what they receive, they combine two antennas into one. Another difference is the proximity of satellites to Earth. They will be sending 3,000 satellites orbiting at 391 miles from Earth. Second company that targets LEO is OneWeb. OneWeb is an UK-based company targeting the low Earth orbit around 750 miles above ground, and they plan to send 48,000 satellites. Their satellite also weighs around 330 pounds and includes a Ku-band antenna with 50 megabits per second internet capability. OneWeb seems to be a direct competitor of Starlink. However, they recently announced they have faced financial issues. The third company that we will look at is the Telesat. Telesat is a Canadian telecommunication company also concentrating on low Earth orbit. In 2020, they announced the plan to send 1,600 satellites. They haven't announced the specification of their satellite yet, but they mentioned that unlike Starlink, they concentrate on business-to-business deals and military applications. Next, we will take a look at European Union consortium led by Airbus. According to Business Insider, European Union is also planning to send a constellation of satellites to space. It will be headed by Airbus and include satellite companies from France, Italy, and Germany. Although their satellite specifications haven't been revealed, they will be focusing on LEO, and it will cost around $7.3 billion. Similar to Europe, China has 3 constellation projects underway. They target 864 satellites with Hongyun, 320 satellites for Hongyan, and undisclosed amount for Galaxy Space. Although they haven't revealed much information about their design, satellite weight is 250 kg and they plan to achieve 1 gigabyte per second internet speed. Next, the Kepler Communications. Kepler is a Canadian startup concentrating on the LEO. They have tested their prototypes and planning to launch 140 CubeSats, smaller cubic satellites. According to their website, their competitive advantage lies in the software-defined ratio, high bandwidth, data transfer technology. Other than these companies and consortium, there are some other proposals from Boeing and Viasat for constellations targeting LEO, but there haven't been much data published for their specifications after the FCC filing. But who has the competitive edge? Who will win in this space? Although some of the companies don't target consumer applications, it seems that Starlink is the only one that started providing consumers with beta testing equipment to test their technology. However, Amazon's Quipper could gain a market edge if they can reduce the satellite weight significantly, causing a significant cost reduction in terms of launch cost. In conclusion, ultimately, success will depend on how costly and how fast each company will provide the internet connectivity. Scaling manufacturing capability to mass produce all the satellites efficiently will also be a key component for success. And as the internet connectivity is a large market, there will likely be more than one winner. To this end, we will need to wait for more data from these companies to reach a conclusion. If you like this video and you want to see more of these videos in the future, please consider subscribing to the channel and give it a thumbs up to this video, and see you in the next videos.